Morning. It is Tuesday, March 31st. This is day 2 of I Can Complete Coordinate Geometry Proofs with additional steps by finding the fourth point or calculating the midpoint. Today we're going to focus more on finding the fourth point. Yesterday we worked on calculating the midpoint. Yesterday we did numbers 1 and 2. You were supposed to do number 3 for homework. We're going to take a look at numbers 4 and 6 today. And that's what we're going to do. We're going to have a quiz on this tonight, one question, and this is a very common 6-point question in the Regents. R is 6, -1. S is 1, -4. T is -5, 6. Let's make that thing look like a triangle. I don't like the R. It's a little too sloppy for me. All right, let's just. All right, so it asks us to prove that triangle RST is a right triangle. All right, no problem. We've been doing that for a couple weeks now. Step 1. RST is a right triangle because its sides fit into the Pythagorean theorem. Again, you need that how do you prove sheet. You need to have that memorized, what we did in the previous, what we did last week. You refer to it if you need to, but you need to know all these how do you proofs. So to do that, I need to calculate the distances. So I'm going to do the distance of RS, I'm going to do the distance of ST, and I'm going to do the distance of TR. RS is 1, 2, 3, 4, 5, 1, 2, 3. That's 25 plus 9. That's 34. ST is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Six squared is 36. 10 squared is 100. 36 plus 100 is 136. And finally, TR is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. 11 squared plus 7 squared. 121 plus 49 is rad 170. So I said here that to show they fit in Pythagorean theorem. A and B are the legs. Rad 34 squared plus rad 136 squared equals rad 170 squared. Show the squares in the radical cancel. 34 plus 136 equals 170. 170 equals 170. And the first part of the question is done. Now, state the coordinates of point P such that quadrilateral RSTP is a rectangle. We did this yesterday. Whatever I do to get from, let me go a different color now. Whatever I do to get from S to R is going to be the same thing from T to P. So from S to R is 1, 2, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3. That's point P. It says to state the coordinates. That's 0, 9. Now, it says to prove that Rstp is a rectangle. Well, let's draw the rectangle in. I'm going to kind of get it onto here. Rstp is a rectangle because, and again, you need to memorize how to prove your different shapes. A rectangle has two things because it has, let me just move this up a little bit. Two pairs of opposite sides congruent and diagonals congruent. So because there's diagonals here, I have to do 6 distances, and I already did 3, so I don't have to recalculate those. I'm just going to continue calculating distances since I have 3 already. In fact, so let me erase 3 here. And now I'm just going to continue on since I found 3 distances already. I'm going to now find the distance of TP. I'm going to find the distance of PR. I'm going to find the distance of RS. TP is 1, 2, 3, 4, 5. 1, 2, 3. That's 5 squared plus 3 squared. That's 25 plus 9, which is rad 34. PR is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Six squared is 36. 10 squared is 100. Rad 136. RS. I'm sorry, I have RS. It should be PS. Is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One squared is 1, 13 squared is 169, 170. So, we've got rad 34, rad 34. We've got rad 136, rad 136. We've got rad 170, rad 170. Notice, even though these aren't the same values, it doesn't matter because the 170s are the same. They still have the same distance. So now, tying it all together, I'm not sure where I'm going to fit this, but I'm doing my best. 3, I said that it has 2 pairs of opposite sides congruent and diagonals congruent. So RS is congruent to TP. ST is congruent to PR. TR is congruent to PS because they have the same distance. So this is definitely a long question for 6 points. We had to prove it was a right triangle. We had to find that 4th point, and then we had to prove it was a rectangle. But as long as you know your how do you proves and you know how to find your 4th point, it's really a pretty straightforward long question. So 5 you're going to do on your own. It's really the same thing as number 4. And now we're going to take a look at number 6. Let me see if I can make this graph a little bigger. I know this isn't ideal how we're doing everything here. I know it's a little sloppy, but based on the circumstances, we're working with what we have here. So it says triangle ABC has vertices A, x, comma 3. I'm going to ignore that point for now because I can't plot x, comma 3. B is negative 3, negative 1. C is negative 1, negative 4. And it says determine stated value of x that would make triangle ABC a right triangle. So we did this. I know that a right triangle has a right angle. I know that perpendicular lines form right angles, and I also know that perpendicular lines have negative reciprocal slopes. So I know that A's got a y value of positive 3, so I'm going to kind of put like a little dashed line there at 3. I want to make my right angle at B, so I need to first find the slope of BC. It's down 1, 2, 3 over 2, which means that the slope of BA must be the negative reciprocal of that, which is 2/3. So I'm going to start counting up 2 over 3. Now I'm not at this line yet, so I'm going to keep on going up 2 over 3. I'm on this line. There it is. That's point A. It's 3, comma 3. So the value of x equals 3. So now I'm going to kind of draw in my triangle. And now it says to justify why triangle ABC is a right triangle. Well, that's the same thing as saying prove that it's a right triangle. So let's get some space and erase this stuff. ABC is, we just did this in number 4, is a right triangle because its sides fit into Pythagorean theorem. I'm going to now calculate those distances. To distance AB, distance BC, distance AC. AB is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's 36 plus 16, which is rad 52. BC is 1, 2, 1, 2, 3. 2 squared plus 3 squared. 4 plus 9, which is rad 13. AC is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 4 squared plus 7 squared. 16 plus 49, which is rad 65. So I said I was going to show that it fits into Pythagorean theorem, so now I'm going to show that it fits into Pythagorean theorem. A and B are the smaller sides, so rad 13 squared plus rad 52 squared equals rad 65 squared. Squares and the radicals cancel. 13 plus 52 equals 65, and sure enough, 65 equals 65. So we're still doing coordinate geometry proofs just like we did before, but now we're doing something first. We are finding a third or fourth point by counting on the graph. We are finding the midpoint like we did yesterday, using a midpoint formula, and then from there we're really just doing the same thing. So your homework, your classwork slash homework, is to finish coordinate geometry proofs applications, and you're going to have a quiz due tonight, which should be attached, which means you're going to take a picture and submit it. Again, you can print it if you have a printer. If not, you can do it on a separate sheet of paper. You don't have to submit your graph paper if you don't have the graph paper to submit, or it's on a separate sheet, but all the work needs to be there. That's it. Again, as always, if you have any questions, please ask me on Remind or email, and that's all I got for you. We're going to move on to a different type of proofs tomorrow, utilizing our quadrilateral properties.